Hello everyone, this is a new video and yeah, of course it's been a lot since the last time I had uploaded my last video and a lot of things has happened and today I just wanted to do a short video just to uh, don't forget the channel and also share all this knowledge in mathematics that probably could help to others in order to improve their skills in math problem solving. And in this time we are going to solve the first question of a Olympiad math problem set. This is provided by the University of Zacatecas in their organization of the Math Olympiad problem, and they create this problem set which is designed for those students who are supposed to solve this exam in 2-3 hours, and the students also could send their questions to the committee in order to make more clear statements about the problems. And the problems are quite good in my opinion. They are a little bit creative in order to solve this problem, so I invite to the public, if they want to just try to figure out each of these problem sets in order to make sure their ability to problem solving, and once they have tried out those problems, then come here again and watch this set of video to just compare their answers and their reasonings in order to improve. Okay, the first problem asks us to find the least positive integer n that satisfy the four conditions, which I'm going to underline or I'm going to remark, which are 3 divides n, 5 divides n, 11 divides n, and also n is a palindrome number. So one of the key points here, probably the most basic one, is since 3, 5, and 11 divide the number n, then we can simply make the statement that the least common multiple of 3, 5, and 11 divides n, concluding that 165 divides n, and hence all the possibilities for n can be found in the set M. Okay, so M is a set which contains all the possible values from n. But there is a principal problem, which is the set M is not finite, so we must bound the set of possibilities to n in order to solve this problem and find the list of all those numbers. And the second point, in my opinion, which is the pretty most important observation, is the next one. Since 5 divides n, it is a good known fact of number theory that tells us that if a number it's divided by 5, then the least digit of the number must be 0 and or must be 5. Okay, so however, if the last digit of the number is 0, then we conclude a rarely case, because since the number is its palindrome, then the first digit and the last digit must be the same. So therefore we cannot have a number that starts with the 0 digit, and hence it is not possible to have the first case. Hence the number ends with a digit 5, okay? And since the number is a palindrome number, then the first digit and the last digit must be the same, and thus the number n is of this form, okay? So the number n could be written down starting with a 5 and ending with a 5, with a x, y, w, and z be a arbitrary digit, and also must be a multiple of 165. But there is essentially 3 cases, because we are looking for the least integer that satisfies this condition, and it could be of 3 digits, or it could be of 4 digits, or it could be of 5 digits, and so on. But if we found a number of 3 digits that satisfy the conditions, then we have already finished the problem. And if not, we need to continue looking for the next set of possibilities. However, we are going to explore that the first possibility is not possible, okay? So because why? Because if the number have 3 digits, then we already know that the sum of the digits is divisible by 3, because the number is a multiple of 3, okay? So 10 plus x must be congruent with 0 modulo 3, and then x it's congruent with minus 10 modulo 3, and hence x is congruent to 2 modulo 3, and it implies that x is of the form 3s plus 2 for a arbitrary s. And also we already know that this x is a digit, so x is bounded by 0, 1, 2, and 9, okay? And with these 2 conditions, we conclude that x could be 2, 5, and 8, and hence we know that there are 3 possible numbers that met this condition, okay? And those 3 options are 525, 555, and 585. But there is a problem, because 11 not divide these 3 quantities. So therefore there is not such x with the property that the number 5 digit x5, it's a palindrome number that meets the 3 conditions which were stated before. And of course we need to know if there is the next possibility, which is that the number have 4 digits, okay? If the number have 4 digits, then since the number is a palindrome number, it must be of this form, okay? However, we already know that if we add up the digits, then we get 2a plus 10, which must be congruent with 0 modulo 3, because 3 divides n. And if we simplify this condition with a arithmetic or modular arithmetic, then we conclude that a must be of the form congruent with 1 modulo 3, which means a is of the form 3k plus 1 for a value of k, okay? And since a is a digit, then a also must be bounded by a set of digits, which is 0, 1, 2, 3 up to 9. And if we take arbitrary values of k and then we obtain that the possible values for A it's 1, 4 and 7, and writing down those numbers we can check manually that we get those three numbers, okay? But the three numbers are palindrome numbers that satisfy the first condition, which are divisibility by 3 by this condition, and also the divisibility by 5 because they all end in 5. But the last thing that we need to do is just ask if the number is divisible by 11. But this time we're lucky because the three numbers met this condition. But we have these three options, but we need just to choose the least integer because we need the minimum that satisfies those four conditions. So the minimum number that satisfies those conditions it's the alternative 5115, and the answer then is this first number. And with this we conclude this first problem, and that's the way in which I did it. But there is so many other approaches. I think this is just only one idea that I've thought, and if you have another approach, please write it down in the comment box below. I'd be happy if I could read another way to do this problem. Also, there is no a lot of things that we can do because clearly this problem is just writing down those numbers and choose the minimum that satisfies those four conditions, and you can simply write down the whole list and just take down the minimum. But this solution I think is not too large enough. So if you have another solution which is a more shorter one, feel free to comment it in the comment box below. And that's all guys for this video. I really hope you'll enjoy this video, and we are again doing mathematics, which is a good thing to do. And for the next video I'm going to talk about the problem 2. So again, everyone feel free to read the problem 2 and trying to solve it, and just look if our answer are the same. So I see you guys in another video, and I'm really happy to can share mathematics in this space. And yeah, this is not a edited video. I just write down the problem, and I just wanted to share with all this solution. And I know this video quality is probably the worst video that I have uploaded, but now I haven't too much time free to just create a very well and structured video. So that's why I use this ugly format. So see you guys